In this video, we are going to solve one-variable equations. Our objective today is to solve one-variable equations with variable on one side, variables on both sides. Some of these may include fractions and also some special solutions. Remember, at any time you can pause or rewind the video to watch something again, and please make sure that you now have the objective written in the objective section of your note sheet. Remember from last year, to solve an equation, we want to get the variable by itself, and that is called isolate the variable. And to do that, we're going to use inverse operations. That means we are going to do the opposite operation in order to get that variable by itself. Here is our first example. 2x minus 11 is equal to 6. So what we need to do is the opposite operation. We're going to add 11 to both sides. And when we do that, that gives us 2x is equal to 17. And we'll do the opposite operation. Since 2 is being multiplied times x, we want to divide by 2. Now we could leave our solution as an improper fraction as long as it's simplified, 17 over 2. We also could write it as a mixed number, 8 and 1/2, or some of you may prefer to use a decimal, and that would be 8.5, which would be fine. The last thing you may want to do when you're solving equations is to check your answer, and we can do that by taking the 8.5 and putting it back in for x and checking our answer. So 2 times 8.5 would be 17, and 17 minus 11 is equal to 6. And that's the great thing about algebra, is we do have a guarantee that it's correct if we check our answer. In the next example, what we want to do is to do the opposite operation and again get the variable by itself. So the first thing we're going to do is subtract 3 from both sides. And when we do that, we have p divided by 7 left on the left side, and that's going to be equal to negative 12 minus 3 would be negative 15. Now again, we're going to do the opposite operation to get the variable by itself. So the opposite of dividing by 7 is going to be, we're going to multiply both sides of the equation by 7. When we have multiplication and division, those are opposite operations, and that's going to leave us with 1p is equal to negative 105. And again, it would be a great idea if you would take the quick moment to just check your answer and to show that negative 105 divided by 7 would be negative 15. And when we add negative 15 plus 3, that's going to equal negative 12. In our next example, we notice that we have variables on both sides. So our goal is to get the variable all to one side. It doesn't matter if you select the 4x to do the opposite or the 6x to move over. But what we might want to do is, since there's another value on the same side as the 6x, is we might want to move that to the other side. So we'll do the opposite. Since it's a positive 6x, we're going to subtract 6x from both sides. 4x minus 6x is going to give us a negative 2x, and that's going to equal negative 18. We're going to do the opposite operation. Since the negative 2 is being multiplied, we are going to divide both sides by negative 2. So x is going to equal 9. And again, you can check your answer by substituting the 9 into both places and checking to make sure it is correct. In our next example, the first thing we want to remember to do is the distributive property. So that means we want to multiply the 5 times the 2x and the 5 times the negative 3. So 5 times 2x is going to give us 10x, and 5 times negative 3 is going to give us negative 15. Again, we have variables on both sides, and your choice is either to move the 7 or the 10x. I'm going to move the 7x, and the reason I'm making that choice is because if I move the smaller amount of variable, then I'm going to be left with a positive variable because 10x minus 7x is 3x. But if you choose to move the 10x, you should come up with the same result in the end. Now we have a one variable on one side, so we're going to then do the opposite operation, which is add 15 to both sides. So we have 3x is equal to 21. And then we're going to divide both sides by 3. And our solution will be x is equal to 7. And again, to check your answer, all you have to do is take the 7 and substitute it for the x into the original equation, and you'll be able to see if your solution is correct. Alright, let's move on. Here again we have an example of the distributive property because we have a negative sign or a minus outside of our parentheses, and we need to make sure that both of these values are being subtracted. So we're going to distribute that negative sign or the minus sign to both of those, making it 4x minus 2x minus 3 is equal to negative 7. Before we continue solving, since these two values for x are on the same side of the equation, we need to combine like terms. 4x minus 2x is 2x. So we have 2x minus 3 is equal to negative 7. Now we'll do the opposite operation. We're going to add 3 to both sides. So we have 2x is equal to negative 4. And then we divide both sides by 2, and our final solution is x is equal to negative 2. Again, you can substitute the value in and check your final solution. Our next example is where we have a fraction. So what we would really like to do is to get rid of the 5. And to do that, we do the opposite operation. Since this is being divided by 5, we are going to multiply both sides of our equation by 5. And that will get rid of the fraction and leave us with an equation with a variable on one side. Now we're going to do the opposite operation to get the variable by itself. The first thing we'll do is add 8 to both sides of our equation. So we have 7x is equal to negative 27, and then we want to divide both sides by 7, which is the opposite operation. So x is equal to, again, this is already a reduced, it's improper fraction. We can leave it that way, or if we would rather have this as a mixed number, 7 goes into negative 27. It would be negative 3 times with 6 left over to create our improper fraction. Or if you would prefer a decimal, that would be negative 3.86 if we round to the nearest hundredth. Our next example involves an equation that has fractions. Now there's several ways to do this. One way is that you could leave the fractions and then you'd need to add or subtract, multiply or divide using the fractions. What I would prefer to do is to see if we could get rid of the fractions. And the way to do that is to look at the denominators, 6, 5, and 2. Find the common denominator. The common denominator is 30. And then we can multiply the entire equation by 30. And when we multiply by the common denominator, that will help us to get rid of the fractions. So the first thing we're going to do is take 5 over 6 times 30 over 1. 5 over 6 times 30 over 1 gives me 150 over 6, and that reduces to 25. Minus, I'm going to take 4/5 times 30 over 1, that gives me 120 over 5, which reduces to 24, giving me 24f. And then I multiply 1/2 times 30 over 1, which is 30 over 2. My result reduced would be 15. Now I have an equation in one variable without the fractions. So the first thing I'm going to do now is to isolate the variable by doing the opposite operation. I'm going to subtract 25 from both sides. So negative 24f then is equal to negative 10. And I'm going to divide both sides by negative 24. So my final solution, f then is equal to a negative divided by negative is a positive, and I would like to reduce this fraction. 10 over 24 is 5/12. Or I could change this to a decimal, and rounded to the nearest hundredths place would be 42 hundredths. Couple of more quick examples. The first one, we have 4d minus 5 equals d minus 5 plus 3d. Again, the d and the 3d are on the same side of the equal sign. We need to combine like terms. So when I do that, I have 4d minus 5 is equal to 4d minus 5. We have the exact same expression on both sides of the equal sign. What that tells me, and again it has to be the exact same, is that no matter what value I would put in for d, it would always work. So in this case, when we're solving this one variable equation, this is infinite solutions. No matter what I put in for the variable d, I will always have the correct solution. Let's take a look at this one. The first thing I want to do is to make sure that I distribute the 3. My result will be 15. Whoops. My pen did a spike there. 15 minus 6w is equal to 10 minus 6w. I do not have the same exact expression, but my variable is exactly the same. So at this point, most of you would know that this is no solution. But how about we do this? We say to ourselves, well, let's make sure that our variable is on the same side. So I'm going to add 6w to both sides of my equation. Well, what that leaves me with, negative 6w plus 6w is 0, so I have left 15 is equal to 10. That is not true. So now this will be a case where there is no solution, because no matter what value that I would pick for w, it wouldn't work. So to wrap up, remember we are going to isolate the variable using reverse operations. Remember your operations of fractions, or to simply get rid of the fractions if you would like to. And there are two special cases that we dealt with: no solution and infinite solution. Please make sure that you have finished your note sheets and then continue with the reflection.